Hello guys, welcome back to my channel, Mason African Motives. So in this platform we shall be actually focusing on exponents and logarithms, which is actually a part that we are going to be focusing on for online classes only. Basically, when you are working with logarithms, what you need to understand is that these two, they are related, exponents and logarithms. So these actually, they work hand in hand, which means for you to understand logarithms, actually you need to understand exponents, which is the vice versa of logarithms to exponents again. So they actually work hand in hand. So what you're going to do is to at least have a basic information or idea of what is happening when we are referring to exponents. So these exponents actually are the ones that some can refer to as indices or index, whereby you are referring to a condition where you have a base and a power depending on a number and an exponent that you'll be given. Let's just take a condition like this. Maybe we are referring to 10 to the exponent of 3. We are referring to 2 to the exponent of -5. So because of these particular numbers which you've got a base and an exponent, there are some certain ways that we can use to simplify such exponents. So I mean, when you are working with these exponents, there are some ways that you are supposed to use, which is from the traditional way of working maths. Then we just work it in a simpler way, which is applying the laws. Like if we are to refer to this from basics of numbers, maybe you were given a condition like you are multiplying these two like this. The actual way of simplifying this was to find the value of this, which is something like 1000. Okay, so this part, don't write it. I'm just explaining where these exponents actually were taken from. This 10 to the exponent of 5, which is 100,000. This was the basic way of doing it, where you have to go through changing the number to 1000, changing this one to 100,000. You multiply the two numbers, you obtain the answer, which is in this case was going to be something like 100 million. All right. So that is where these exponents were taken from. Now they see that instead of us doing this longer way, we can apply what we refer to as the laws of the exponents. So these are the ones that I want us to write down because they're very, very important. So we've got laws of exponents, which are the ones that we use whenever we are simplifying exponents. There is no way you need to understand. So the reason why I'm gonna work with these separately, so that we just understand what's happening on each law, then we will combine them now working with questions. Okay, so I'm going to explain the first exponent in this way. Let's say we have a condition where we are multiplying at the bases which are the same. So in this case, what is important is this x and this x. These two are the same. Okay, so on this condition, you are going to add the exponents. So whenever you are multiplying the bases which are the same, you're going to add the exponents. So what does this mean? Let me have it here. All right. Let's say we have a condition of like that example that I gave you previously, where I used the traditional way of doing it. Let us now work it with the laws of exponents like this. If you are to cross-check here, we've got 10 and we've got 10 here. These bases are the same. These are the numbers that we are referring to. And we are multiplying, so we're just going to add the exponents, which is in this case is going to be 10 to the exponent of 3 plus 5. So we are going to add, which is 10 to the exponent of 3 plus 5 from your calculator, which is going to give you 8. So as we can see, that is how we are simply doing this. So it can be a condition where you're given numbers, or it can be a condition, maybe they are letters actually. Maybe you're given a letter of x to the exponent of 5 times x to the exponent of 7. Still, it is the same thing. We have got x here, we've got x. So take note, guys, never make a mistake to multiply to say 10 times 10, it's 100. Then you say to the exponent of 8. This is wrong. You don't multiply these numbers. As you can see, we didn't multiply x, we just added the exponents to the same x that we had here. All right. So here, we are going to do the same. We've got x, we've got x. So let's add because we are multiplying. So it's 5 plus 7. All right, which is x to the exponent of 5 plus 7, which is 12. So that is the application, or what the first law is simply referring. All right, number 2. X to the exponent of m, which can be division now. So in terms of division, I can write it in simpler ways. I can do it like this: divide by x to the exponent of n. Or it can be written like x to the exponent of m divide by x to the exponent of n, like this. So this is the same thing. It's still under division. So when you are dividing, this time you subtract the exponents. So it's m minus n, right? Which is the same thing here, x to the exponent of m. So this, the one that I'm referring as the exponent, is the power. So it's x to the power m minus n, or x to the power m minus n, like that. Okay. So which is the same thing, just like what we're doing here. We can simply apply this law, just like maybe we are given 10 to the exponent of 7, which is dividing 10 to the exponent of 2. So this is the same as we are given it as 10 to the exponent of 7 over 10 to the exponent of 2. It means one and the same thing. So what matters is that you are dividing and you are given what? The bases, which are the same. So you're going to subtract the exponents. So it's 10 to the exponent of 7 minus 2. All right. 7 minus 2 from your calculator, that's going to give you a 5, which is the same thing like this one, because it's one and the same question. So that's it, guys, for this law. As you can see, working with laws can make things much easier. All right. Then another law. So you can be given a condition, maybe this is one of the most important, but I'm going to explain all these laws. I'm going to explain them further. So let's say we've got m and we've got n, like this. Okay, since I'm using m, let's just continue with this m. So given a condition, this is m, so this is going to give us x to the exponent of mn. All right, what does this law mean? Whenever you are given an exponent like this, guys, we have got 2 to the exponent of x, like this, all right, to the exponent of 2. Whenever you are given an exponent and there's also another exponent outside of the bracket, you multiply the exponents, these two. So this is going to give us 2 to the exponent, you multiply, so it's 2 times x, which is 2x, like this. So this is the law that you are applying here. You multiply the exponents together. Take note, these two exponents, they are under 1x. They are different from these two where we had different x, like this part. All right. So take note about this law, because it can be given in this way. That's number 3 there. It can be given in this way. Maybe we have got x to the exponent of m, which is multiplying x to the exponent of n. All right. These two, they're inside a bracket like this. Then there's another exponent. Let's say there is a. So here I'm just extending this exponent, this law. Let's just say this is now item 2. This was now item 1. All right, so I'm going to extend this. As you can see, we are still applying the same thing, but here, as you can see, we are given a part where we've got x. So this one, we can just write another x, another base here. Maybe we can use y. Okay, so guys, don't confuse, don't freak out, right? Don't confuse here, because if I use this x, I want to extend this law, because if I use this x, it's gonna come back here, and I don't want this condition where I'm explaining two laws at the same time. That's why I have to change this later. I hope you understand what I'm saying, because if I have x to the exponent of m times x to the exponent of n, I'm back to that law where I'm supposed to add the exponents. If you remember that, then there's gonna remain this exponent of a. I multiply, but I want to explain in this way where these two are different. All right. Still under the same law, this a is the exponent, so it's going to multiply the exponent of m, and also is going to multiply the exponent of n, just like what we said, an exponent multiplies an exponent. But because we have got two terms inside the bracket, so this exponent is going to affect everything inside the bracket. So this is going to give you x, you multiply a times m, that is am, y to the exponent of a times n, which is an. So like this, you've got your answer. Or you can even remove those brackets, they're not even important now. So this one can just be x to the exponent of am by y to the exponent of an. So this exponent multiplies everything. Like let's take this example here. You are given a condition, maybe there is 2x to the exponent. Mostly that's where you apply this law. All right, like this. If you are to consider here, there are so many questions which have been asked in this manner, where there is an exponent 2 there outside of the bracket. So not to confuse this part, guys, make sure that you write everything inside the bracket in terms of exponents. All right, what do I mean? I'm given 2 here, so this 2 is the same as writing as 2 to the exponent of 1. Remember, any number to the exponent of 1 remains as it is. X to the exponent of 1 is going to remain as x. So 2 to the exponent of 1 is going to remain as 2. We haven't changed anything, but we want to write this as this part so that we can apply the laws. All right, so that's, I think it's clear. So we can multiply, that's 2 times 1, which is going to be 2 to the exponent of 2. So you're multiplying 1 and 2, which is 2. X to the exponent of, you multiply 3 times 2, which is going to give you a 6. So this is what you're doing. You're multiplying 2 to 1, that's 2. 2 to 3, that's 6. You multiply everything just like what we did here. A and m, that's am. A and n, that's an. So that's the idea there. So 2 to the exponent of 2, which is 4. X to the exponent of 6. So this one is going to remain like that. There is no effect there. It's just going to remain in its original manner, or from where we have taken it as it was. So like I was saying, that each and every law is a concept or a part that is going to play. We have a part, each and every law, where it is going to play its role. What about on a condition? Now I think I'm number 4, another one. What about I'm given a condition where I'm having a number that is being raised to the exponent 0, because we said when it is raised to the exponent of 1, it remains as it is. X to the exponent of 1 remains as x. What if I raise this to the exponent of 0? What am I going to have? All right. Any number that is being raised to the exponent of 0 is going to give us a 1. And this must be taken into consideration. It must be taken into consideration. What do I mean? Let's say I'm given x plus y, everything to the exponent of 0 like this. What does it mean? It means this whole bracket is raised to the exponent of 0. And take note, there is a plus here. So we can't write this as x to the exponent of 0 plus x to the exponent like this. This is wrong. Very, very wrong. Because of the bracket that we are given. We are affecting the bracket. So it's like we are not considering this. We are considering the bracket. So the bracket is just representing the same thing as x. So this one is going to give us a 1. There is no effect from what is going to happen there. So the reason why I am explaining this is that maybe if it was given, maybe this question was not given like this, it was maybe given as x to the exponent of 0 plus y to the exponent of 0 like this, everything to the exponent of 2 like this. What does it mean? All right, instead of you focusing with these 2, because these 2 cannot affect you because there's a plus, it can only affect when there is a multiplication, not a plus like this. Maybe you were given x to the exponent of 0 by y to the exponent of 0 like this, everything to the exponent of 2. That's where you can apply that law of making these 2 multiply everything inside. That is 2 times 0, which is x to the exponent of 0 times 2 times 0, which is y to the exponent of 0. Then you say x to the exponent of 0, which is x to the power of 0, that is 1, times y to the exponent of 0, that is 1, 1 times 1, which is 1. But on this one, it's not the same thing because of this plus. So when there is a plus or a minus, a sign that is separating the 2 terms, you can't apply this consideration. No, it's impossible. So what am I going to do when I'm given this? I'm going to do the same. I'm just going to find, okay, so this one is done here. This is another question. All right. Here I'm going to find the value of x to the exponent of 0, which is 1, plus y to the exponent of 0, which is 1, because we said any number to the exponent of 0 is what? It's 1. Everything to the exponent of 2, this one. 2 is not going to affect this. What am I going to do here? I combine 1 plus 1, the bracket first. So 1 plus 1, that is 2. Everything to the exponent of 2. So now that's where I'm going to apply the exponent now. 2 to the exponent of 2, which is going to give us a 4. So be very, very careful about this law. Sometimes how they might ask the questions still under the law, but they will be trying to just confuse us in different manners. So it's one and the same thing there. So what you're going to do is to try questions. That is what you're going to do in this case. Try more questions applying these laws. Okay, then let's just talk about a negative. I think this was no, 5 or 4. Okay, let's have a negative exponent like this. Maybe you are given x, which is raised to the exponent of a negative like that. Okay, so whenever you are given this condition, for you to remove this negative, you're going to write it as 1 over. Whenever you're given a negative, you write it as 1 over. So this is going to be 1 over x to the exponent of n. So what do I mean? X to the exponent of minus 2 is the same thing as 1 over. Just to remove this negative, that's 1 over. You have removed the negative. So just imagine closing the negative here. Just imagine I close this negative. What is going to remain if I close this negative? I'm going to remain with x to the exponent of 2, because the negative here is the one that is being removed by. So I'm just removing this negative. So if I close the negative, I'm going to remain with a 2 there. This negative that I closed here is this that is represented by 1 over. That is where your negative has been used. So you're just going to write this as a positive. Okay, so if you take it in that way, it's going to be easier for you. X to the exponent of minus 10, 1 over, I have removed the negative, then I'm remaining with what? X to the exponent of 10, just like that. So it can be so easier. So that's another law that you can use. Then the last one that I'm going to explain is on a condition that we are given x to the exponent of m over n, where you are now have a fractional exponent, an exponent in terms of a fraction. Okay, so this is going to give us the nth root of x to the exponent of m. So take note, the denominator here is the one that is inside the square, the root sign. The numerator here is the one that is representing your exponent. So this can also be written like the nth root of x to the exponent of m, like this. It's still one and the same thing. It means one and the same thing. But let's say, okay, in fact, I watched here, I was supposed to maybe start with this one. Maybe it is like this, x to the exponent of 1 over n. We are just having a 1 there. What does this mean? It means it's going to give us the nth root of x, like this. So whenever you are given the nth root of x, it means that was from 1 over to the exponent of 1 over. So what do I mean? I mean, if I'm given the 5th root of x like this, okay, it means x to the exponent of 1 over, as you can see, this is our n, so it's 1 over n, which is 1 over 5. Take note, guys, do not confuse this part here. Okay, do not confuse this part here. This is what we had. 1 over n. N and x, the nth root of x. So this is what we have, the nth root of x. So you see, this is our n. And our n as a fraction is 1 over n. So this is 1 over 5. But if it was given like this, the cube root of x to the exponent of 5 like this, what does it mean? How can I rewrite this? Because it's a matter of rewriting now. So this is going to give us x. Remember, we said this represents your denominator, just like this 5 is your denominator. So it's not going to change. It's going to remain as the denominator. So it's going to be the denominator, and 5 is your exponent, your numerator. So it's going to be 5 over 3. So just like this, 5 is your denominator. Okay, what about this one, which is our numerator, x? Remember, I told you guys that x is the same thing as x to the exponent of 1. So your numerator here, your exponent here is 1, which is your numerator here. So it's the same thing. Here we've got 5. This is our 5, which is the same thing as a 1 here. The denominator here is 3. The number inside the root is 3. That's your denominator here, which is 3. Here it was 5. So are you seeing it's one and the same thing? But it can be the 5th root of just x, or it can be the cube root, then we are given a certain exponent. So still it's one and the same thing. So what actually need is you guys to try much questions that you're going to work from different platforms and so forth, so that it can be easier for us. So if we are to cross-check, there are so many questions actually that we can refer or that you can work on. Okay, on this exercise we've got use the laws of indices to find the answer to each in the table below. Okay, so we are explaining the law, then the answer. Okay, so here I'm worried about the answer here. Okay, so these are the questions that they can actually ask, typical questions, how they can ask these questions. So you can actually try as much questions as possible. As much questions as possible. As much questions as possible. So these are some of the questions there. All right. So that's on exercise 4.1 there. From this book, it's on actually on page 85. All right. Then another part actually on the same exercise will be this one. I don't know if it is not going to affect here because it's not clear, but that's the exercise there, which is a continuation actually. So this is actually a continuation. So actually these are the questions that they can ask, so we can try as much questions as possible. As much questions as possible there. All right, so I think that's the best that we can have, and we can apply. Where we have questions, we can actually talk about them, but that's how actually you can apply these. Just want to explain this one. Maybe it can be found confusing, where we are given a to the exponent of a plus b over a to the exponent of a minus b, like this. Actually, this question, it was supposed to be written like x to the exponent of a plus b, like this, over x to the exponent of a minus b. This was supposed to be the question there. So I think we can just try and work out this question and see what's happening here. So looking into the question, we are going to see that this part here, we are actually dividing. Remember from the division that we talked about last time, we are dividing and the bases are the same. We've got x here and we've got x, so definitely we are going to apply the laws of exponents, where we said you're going to subtract. So if we are to subtract, what are we subtracting actually? All right, we have got this part on the numerator, which is a plus b, minus the exponent of this one, which is in the denominator, which is a minus b. So we're going to subtract a minus b, like this. So take note here, I'm opening the bracket. Why am I opening the bracket? Because there's a negative which is supposed to affect everything here. So we are going to have x to the exponent of a plus b. You multiply by a negative, so it's negative times a, which is negative a. Negative times negative here is now a plus b, like this. So take note, it's negative times a, you multiply everything, that's negative a. Here it's negative and a negative, so a negative and a negative gives us a positive. All right, but a positive and a negative, they give us a negative. Just like in your, okay, a negative there, a positive and a positive, that's a positive. All right, so now we can actually collect like terms. We've got a minus a, so as you can see, these two can cancel. A minus a, that's a 0, and we are left with b and b, so you can add b plus b. B plus b simply means 1b plus 1b, so it's simply adding 1 plus 1, which is 2b. So because 0 plus 2b, like this, 0 plus 2b, 0 does not have effect, this one. It's like there's nothing that you're doing there, so you're just going to remain with 2b. It's like 2b is added to nothing, so it's just going to remain as it was. But if it was added to something, then it's going to change. So that's the effect also, that you can tell that when something is added to nothing, it remains as it was, but if it is added to something, it can change actually. So that's actually how these questions can be, how they can ask these questions. So what we're just going to do is to work on match questions and revision so that we'll see how they ask these questions. So till we meet again in another episode where we shall be working on logarithms, applications of logarithms, and some also laws of exponents. So that is for the class. We ask the questions, we work on the questions from the textbooks, then other revisions, we'll talk about them as we continue our classes.